All right, let's look at an example problem of how we can add the z-table, or the standard normal distribution. Assume that women's heights are normally distributed. This is the key when you take your test and you say, well, I don't know what table to use, because you're going to learn that there's other tables, but this right here tells you that you're going to use the z-table. With a given mean of 63.4 inches, so this is women's heights, and a standard deviation of 1.8 inches. If a woman is randomly selected, find the probability that her height is between 62.9 inches and 63.9 inches. So the probability is found by looking up values in the z-table. But what we have to do, we have to find these z-values. Remember, the z-table is with a standardized mean of 0. Well, we have two different means here, so what we have to do is we have to standardize the lower value and the upper. So we do this by plugging into our formula our x value minus the given mean divided by the standard deviation. This gives us a negative 0.28. Do the same thing here, our x value minus the mean divided by the standard deviation, and that gives us our other x value. So between, we want the probability between these heights would be the area between these two z-values. Always, always, always draw a picture, because I think that will help you see what you're actually. So the first thing I would do is just draw the picture of the information given to you with the mean of 63.4, and we want to know this area, this probability between 62.9, which is to the left of the mean, and 63.9, which is to the right of the mean. If you notice, if we see this, where we make the standardized mean 0, and we just found these z values, if I find this area and subtract the two, that would give me this area here in the middle. So what I do is I look up my table, I look in the z column, the negative 0.2, and then follow the 0.08, and I get this 0.3897. That's the negative one. And then the positive one, I get 0.610. See this? So here is my negative 0.28. There's the 0.3897. And then I have my 0.28, 0.610. And again, I'm going to subtract the two values, and this gives me my probability, 0.2206.